These are the solutions for Integrated Math 2, Chapter 9, Quiz 1, Lessons 1 through 2. Question 1 asks us to draw a net for the figure on the right. This is a pyramid with a square base, so it doesn't need to be to scale, but we want to be able to know what it is representing. So it's composed of triangles and a square base. All right. Use the polyhedron at the right for exercises 2 and 3. A polyhedron is just a shape with multiple sides. So poly means multiple sides. Hedron means shape. Okay, give the number of bases and their name. Bases are the ends. So this has 2 bases, and they are octagons. And so that means there are 8 sides. So 1, 2, 3, 4, 5, 6, 7, 8. Since there are 8 sides, there are 8 faces, and each of those is a rectangle. Now, suppose the area of each base is 47 centimeters squared, and the area of each lateral face is 20 centimeters. What's the surface area of the polyhedron? To find the surface area, what we need is the area of each base, which was 47. And how many bases were there? There were 2. And what is the area of each lateral face? It was 20 centimeters squared, and there were 8 faces. So we're going to multiply that out, and what we end up getting is 254 centimeters squared. All right. So up next, the next problem say surface area. Find the surface area of each figure to the nearest whole number. Okay, so what we have here is a prism. So what is the surface area of a prism? It's lateral area plus the 2 bases. Lateral area is equal to perimeter times height. And what's our perimeter? It's 13 plus 7 is 20. Then on the other side, it's going to be 13 more and then 7 more. So that's another 20. So our perimeter is 40 inches. What's our height? Our height is 11. And then what is the area of our bases? It is 13 times 7, which is 91 square inches. Our lateral area is 40 times 11, which is 440 inches squared. So our overall surface area for number 4, this prism, is 622 inches square. Number 5 is a cylinder. We're still finding surface area. So we end up using the same kind of formula. It's lateral area plus the 2 bases, but these bases are circles. So my lateral area is equal to 2 pi r h. It's the circumference of the circle times the height of the cylinder. So that is equal to 2 pi times 16 times 25. So we have 32 times 25, and that gives us the lateral surface area is 800 pi. And then the area of the base is pi r squared. So pi r squared. And r is our 16. So we get pi times 16 squared. and 16 squared ends up being 256. Then there's our pi. So our surface area is 800 pi plus 2 times 256 pi. 800 plus 2 times 256 is 512. We end up with 1312 pi centimeters squared, and we can approximate. If we use pi is 3.14, we get 4021.77 centimeters squared. And then moving on to problem number 6, our surface area, once again, is the lateral area of a pyramid, but our base, we only have one base. So make sure you only include one base. Our lateral area is equal to 1/2 of the perimeter times the slant height. Our perimeter is 1, 2, 3, 4 times 7. So it's 4 times 7, which is 28. Our slant height is 7 centimeters. And so that makes our lateral area equal to 1/2 7 times 28. And that gives us 14 times 7. So it's 49. It's 98 centimeters squared. And then our base, this is a square. It's 7 by 7. So it's 7 squared, which is 49 centimeters squared. And that makes our surface area equal to 147 centimeters squared. Now, problem number 7 is a little bit different. This gives us the radius and the height, and we're going to need the slant height, because if I write my surface area formula, it's equal to lateral area plus 1 base. I'll stick with the things that I already know. My base is equal to pi r squared, and my radius is 5 meters. So 5 squared is 25, so I have 25 pi meters squared. My lateral area is equal to pi times RL. Problem is I don't know L. I do know R. But I can find L from the relationship. Since this is square, I can use the Pythagorean theorem, which says that the slant height is equal to this base squared plus this base squared. That's 144. That's 12 squared. And this is 25. 5 squared is 25. So I add those together, which is 169. So L is 13. So if I square 13, I get 169. So coming back up here, I have pi times 5 times 13, which gives me a grand total of, I have 25. I have 65 right here. 65 pi. And so 25 plus 65, my surface area, is equal to 90 pi meters squared, which is approximately, we use 3.14 for our value for pi, it is 282.7 meters squared. Okay, now for problem number 8, we have 6 triangles building part of a net for a polyhedron and a hexagon. So for me, the only way I can think to put this together is there's a hexagon, here are some triangles, and that's a bad triangle. And looks kind of like a flower. If we fold it up, what kind of polyhedron can it be? It's a pyramid. Now each of these triangles is part of the lateral faces. So if I'm thinking about surface area, how many bases do I have? It says a hexagon. A is 1, so I have 1 base. And then how many sides do I have? For my lateral area, I have 6. So I have the area of 1 base. So hexagon, 6 meters squared, 6 meters squared. And I had 6 triangles, 6 triangles of 3 meters squared times 3 meters squared. 6 plus 6 times 3. That is 6 plus 18 meters squared, which is 6 and 18. What is that? That is 24 meters squared. Now for the last problem, reasoning, explain how you would find the surface area of the solid figure shown at the right. There are many ways to explain it. You could say that I am going to find the surface area of that pyramid on top, and then the surface area of the prism on the bottom. I could talk about taking the measurements and using lateral area of the pyramid. There's no base, plus the lateral area of the prism, plus 1 base. There is substantially more than one explanation, but as long as you talk about essentially taking the area of the top, taking the area of the bottom, plus that base, adding them together, you have the answer.